Hello. Hi, Paul. Do you hear me?
No.
Yes. Yeah, I do hear you.
Are you wanting me to start? Because I didn't hear
Let's.
any introduction to the
Yeah,
second
I
part
give it
of.
another.
Yeah. I'm
People
actually
are still.
checking again my setup. I haven't changed anything, and still I have to change a lot before I could get your slides up again. Let's see if I have this in full screen. That goes well. Okay, Suzanne dropped off by accident. Oh, there's Suzanne. Excellent.
I was just muted.
Oh, okay. Sorry. Then, yeah. Welcome to the second DNSOP session this afternoon. We have 3 presentations. The first one is by Paul Hoffman. Again, this session is being recorded. Note taker is the speaker here, Paul Hoffman. So be kind to him for this session, for this presentation. Or
I think
you
there's
can.
no need for that. Tim already started beating me up in the last session for this one, so.
All right. Okay. Sorry, Paul. This session being recorded. If you have questions, please raise your hand by the microphone. You will be queued, and we can allow you to speak on the microphone or on the video. If you want to use the video, that's fine. And use the Jabber room if you want to ask a question in the Jabber room. Mike Cologne, and then ask your question, and we will monitor the Jabber room. Good. We go ahead. Paul, please take the floor.
Okay, thank you. In case anyone noticed that the lighting is slightly different on my face, that's because we're starting to have sunrise here. Welcome to 6 o'clock in California. So this draft, very short draft, I put in a few weeks ago. This is up for working group discussion, as Tim said in the last session, although he seems to not like it. Hopefully he can say more. Next slide. So the motivation for us looking again at the IANA registry for what is required for DNSSEC algorithms, in order to get a registry entry, is the fact that GOST BIS, RFC 5933 BIS, actually needs to be on standards track because algorithms that describe DS records currently are standards required for the IANA considerations. Now, just to note that other IETF working groups, so like TLS, SMIME, all these other ones who do crypto, have all of their registries either be expert review or RFC required. They do not require standards track. So I thought, you know what? Yes, we're doing GOS now. We could just put it on standards track, even though basically I believe in this working group, approximately 0 people who are reviewing the draft will actually understand the crypto well enough to want to put it on standards track. Why don't we deal with this now? Because there will be more crypto like this, which is what is generally called national crypto that is important to an individual country or possibly a region, that people want to document and want to get code points for, so that, in this case, DNSSEC can use them. So that was my motivation, and it's a super short draft. Next slide. So DNSX were the folks who put together RFC 6014, or actually it was passed in the working group. It made all of the new DNSSEC registries, which is, at the time in 2010, RFC required. However, we forgot that DS records were not new, and therefore they were not covered by. When I say we, it was sort of interesting. I had to figure out, when I was looking at this draft, I said, oh God, who made the requirements and missed DS? And I looked at RFC 6014, and guess what? I'm the author. So, whoops, I'll say we, but in fact, we could also say I forgot DS records here, although no one seemed to notice it. Also, even though after that, when DNSOP defined NSEC 3, they also went with standard required instead of what everyone else is doing. So like I say here, TLS, IPsec, SMIME, they all go with either expert review or specification required. In my mind, there's nothing special about DNSSEC relative to TLS, or IPsec, SMIME, all the rest. So I would think we would follow the IETF, the general way that the IETF does it, which is either standard required, RFC required, or in fact, just expert review should be fine. One of the things that, like, for example, Tim said earlier, oh, we don't necessarily want just anyone getting an algorithm. It hasn't negatively affected like folks like TLS, where there's a lot more interest than in DNSSEC, and certainly a lot more adoption. So I'm not sure that we should consider ourselves special here. Next slide. So this can be done quickly if the working group adopts it. And if we do that, then we can obviously continue to work on RFC 5933 BIS, but then it doesn't have to be standards track. It could be informational, like most of the other national crypto RFCs that are out there. Basically, we're the only working, or DNS is the only place where national crypto has to be a standards track RFC. And this is nothing new, by the way. I mean, when I was chairing the SMIME working group 20 years ago, it was decided that the national crypto ones should all just be informational. That didn't have any negative effects on anyone. And again, to be clear, let's not think of this just as GOST and the Russians. There are half a dozen other countries that have national crypto, some of whom have already gotten RFCs in other protocols. Especially SMIME and TLS. Why not have DNSSEC be pretty much similar to the others? So that's it, short presentation. Happy to take questions.
Thank you, Paul. Sam, please go ahead. You have the mic.
And I am sitting.
Yeah,
Excellent.
I do hear you.
This tooling, I say. Paul, you're citing SMIME and TLS, and I would say that those are actually not applicable precedents in this case. And it has to do with the nature of the parties involved. And I think in SMIME and TLS, these are far more end-to-end systems where only the parties at the ends care. With DNS, a lot more parties in the middle care about validating the results. And I think it is then in the interest of the internet to have a more limited and more standardized set of algorithms. That said, we did 6014 back 10 years ago. I don't recall the conversations that led to that. And so I'm happy to defer to others that do. But I do think that the precedents that you're citing are not particularly applicable in this case.
Sam, would you say that that was also true for IPsec?
I think that fits more into the SMIME and TLS bucket.
Okay, so do you believe DNSSEC is actually unique this way?
I believe it is different from the ones we've cited.
Okay, but are there other ones that, I mean, those were the only ones I went and looked at, but if you can think of another one that we could go compare to, that would be great.
If I do, I'll let you know.
Great, thanks.
Hello?
Benno, were you going to ask for someone else in the line?
Sorry, yeah, I was muting myself again. Please, Victor, please
Yes.
go ahead.
So I think the previous speaker covered my point pretty much. I agree that DNS is a bit different in the fact that there are many intermediate parties that look at the details of the message between producer and consumer and that need to understand potentially and accurately forward the additional signatures and so on, and that there's more of a need in DNS to have the algorithms be understood universally.
So, Victor, given that, do you believe we should upgrade all of our algorithms to be standard required? Because at this point, it's only DS and NSEC3.
I think all of them should be RFC required, yes.
Well, RFC required is different than standard required. RFC required would be fine here. What we're up against is standard required.
Probably that too, but I haven't given it enough thought yet to understand
Okay.
the difference.
Great. Hopefully people do. Thanks.
Thank you. Next in queue is Ben.
Hi.
Hi.
Okay. So just I don't have a strong feeling about this, but I wanted to highlight two differences that stuck out to me. One is that TLS cipher suites, and I suspect a lot of these other spaces are larger. They are a lot of them are 16-bit. This is an 8-bit space. But actually, I do think there are. I just sort of poking around IANA right now. I was trying to think of other registries that are similar. One of them is client certificate or the certificate type. So there's a TLS client certificate type registry. That's a single octet, and it has sub-ranges that are standards action. It has a sub-range that's standards action, but most of it is specification required. That might be a relevant case. PGP is another potential case where that sort of matches Sam's rubric of signatures that might need to be validated by a variety of different parties. The PGP registry is IETF review. So it seems like there's a fairly diverse range of practices here overall. I think one thing that I noticed while looking at this is that the DNS security algorithm numbers registry shows the references and also indicates their status. It distinguishes. So far, everything there is listed as proposed standard. Also, currently, the IANA site shows DNS security algorithm numbers as RFC required. Maybe I'm looking at the wrong registry.
You are. We're
okay.
talking specifically about the DS records. So I thought I said that fairly clearly in the draft.
Anyway, so I think it seems like it. If there's it seems like it ought to be possible to provide an indication of at least the status of the draft. That if, for example, we were specification required, then hopefully it would be clear from the registry which of these ciphers correspond to IETF documents and which of them are other parties.
Sure, and that for anything, for all IANA registries that are specification required, you have to list the specification, and so it's clear if it's a draft or an RFC or simply an academic article.
my biggest concern here would probably just be code point exhaustion, especially if, as you say, you think that these.
So we're at 3 of the possible 256. The way that we dealt with the possibility of code point exhaustion in the other RFC is to say, at the point where the registry is half full, the working group should look again. At this point, that's probably into the next century.
So, if that's the plan, then you can codify that easily by making half of the range.
Well, and again, the RFC says the RFC that this is updating already says that.
Okay, I'll take another look.
Sorry, I muted myself again. I want to cut the mic line now. Jim, please go ahead.
Thanks, Benno. A few points to make here. I think we should adopt this document and progress with this. It's a no-brainer. I think we need to do something with the issuance of code points for these crypto algorithms that's broadly in line with what's done for crypto code points in other working groups, so things like TLS and SMIME and all these things that Paul outlined before. I think the current mechanism we've got for these DNS crypto stuff is too heavyweight. I think we need to be a little more flexible about how we approach these things. The point that Ben was making about code point exhaustion is, of course, a valid one, but as Paul pointed out, we're probably going to be worrying about that in 100 years' time, and I don't think that's going to be my problem or anybody else's problem that's currently in the working group to figure out a solution for that. We've got plenty of room at the moment. I think we can worry about this later, although it's still a valid point to make. And I think some of the things that were said before about the concerns about end-to-end interoperability and so on are valid, but really I see this as just being not that much different in principle from how we deal with DNS resource record types. Some implementations can and can't deal with them. And so maybe we need a separate document which talks about mandatory to implement crypto or optional to implement crypto for DNSSEC. I think we had something like that before back in the days when we had DSA kicking around. Maybe it might be an idea to think about that as a potential way of dealing with this problem about the end-to-end aspects that Sam and Ben mentioned before. But I think that's a separate issue from the simple, pragmatic, almost bookkeeping exercise of issuing a code point when a new, useful crypto algorithm emerges for DNSSEC. I think we need to keep those two things separate. Thank you.
Thank you, Jim. Next in queue is Andre Suri. Please go ahead.
Hi, this is Andre. So I'm becoming more and more confused on what the group wants, because we were speaking about not like growing up the camel and requiring the support from the implementations to introduce a new RFC, and now we are going the other direction, like whatever, just relates it so everybody can get a code point. So this is very confusing to me. Especially for a registry that's only 8 bits long. So this is one thing. The other thing is that I kind of agree what Sam said at the beginning, that the interoperability in the DNSSEC is important more than in other protocols, because there's a huge inertia in the DNS world. It doesn't happen in TLS. The servers get upgraded more quickly. The clients get upgraded more quickly. This doesn't happen in DNS, and we must reflect this real world situation in our standards. Because just think about how long it took IANA to accept the ECDSA records in the root. It took years. So it's nice to have a flexible registry, but it doesn't match what happens in reality. So I'm definitely sure that it needs more than expert review. I could live with like aligning with RFC needed with the other algorithms, but I think we should be very strict when accepting new algorithms. We should accept the
just to
guidance
be
from.
clear, Andre, just to be clear, the current draft says RFC required. So it doesn't sound like you're pushing against what's in this draft.
So what I'm saying that we should be very careful about relaxing the requirements.
Okay, thank you. Any comments? Reply? Next in queue. Next in queue is
Very much
Michael.
against.
Thank you, Andre. Next in line is Michael St. John's. Please go ahead. Michael?
Unmute.
Mike, we're not hearing you.
No. I will keep your mic open, but I will go to Warren, and in the meantime, try the microphone. Warren, please go ahead.
Sorry without so I think I largely agree with what the draft says, and I think what Jim said. Standards track feels very heavy for this. And, many people have relatively strong views on national crypto stuff. If we require things to be standards track, no matter what it says, it still feels as though we are going to be sort of endorsing national crypto stuff. If we simply have it as RFC required, like pretty much all of the other registries do, it's still a really high bar, right? You still need to get an RFC. It still needs to go through a process. It still needs to be reviewed. So I don't think that really lowers the bar very much. It just sort of changes the tone of things. Many of the TLS registries actually have disclaimers in them, right? Notes, which say things like this is not an endorsement or not. We already have the sort of check valve so that when we get close to running out of code points, we will have to reevaluate this. And again, it's we can get 256 thingies in this code point space. We've hardly used any at all. I agree with people that interoperability is important and the DNS is different to things like TLS. But I think that that's actually sort of an argument more for why we want to make it so that people can actually get things put in the registry. If we don't make it so that it's possible for people to add things to the registry, people are just going to start squatting on code points. And I think that's a much, much, much worse outcome for interoperability. If we have it RFC required, people can ask for something in the registry. When we can expand this to have a note section about recommended, not recommended, like many other registries have. So I think this is a no-brainer and we should just do it. Sorry, rant over.
Thank you, Warren. Sorry.
Can you hear me this now?
Yes, please go ahead, Mike.
Okay, sorry. Paul, this matches up mostly with something like broadcast cable or television where that's encrypted. So it's a point to multi-point system, and having one or few algorithms makes a lot more sense. That's for the data protocol. You were asking about should it apply to the rest of the stuff with respect to, say, the transport protocol, TSIG. It could be, you could actually have different policies for both of those if you needed to. As I've been listening to this discussion, one of the things that we should be thinking about is how do we get interoperability, or how do we maintain interoperability? And the national cryptos should be, in some ways, a second signature on a standard algorithm set. You should have both the national crypto and something that everybody implements on the data that you're signing. So.
Benno, you're muted again.
Okay. DKG,
Yeah, sorry, Valerie. Oh, please go ahead, Suzanne.
Yeah, just go ahead in the queue. DKG, I guess.
I think Valerie is still there.
I'm here.
Yeah.
Okay. Valery Smyslov. I am in favor of adoption this draft because it makes the situation more consistent. The situation with Ghost draft rises because exactly one DS IANA registry had a stricter policy than the other registries that needed for registering Ghost, a new Ghost signature. So make all this registry consistent is a very good thing, and I think RFC required is a good margin that will have that will allow to have enough scrutiny when reviewing candidates for new IANA code points, and at the same time it will not place a very high bar so that national crypto is able to get standard IANA code point without too much difficulty of proceeding with standard track RFC. So I'm in favor of adoption. I think it's a very useful document.
Thank you. Last in queue is Daniel. Sorry, Eric, we closed the line after Daniel. Please, Daniel, go ahead.
Hi there, this is DKG from ACLU. I'm just observing what I noted in the chat, which is that I think using PGP and TLS as examples for this is a bad idea. PGP and TLS are both protocols that have explicit negotiation mechanisms, and they tend to be pairwise. That is, the sender knows who the recipients are in PGP, TLS is between a client and a server, and they can sort of figure out what they both need in order to communicate. And DNS is not. DNS is unilateral. And I think it would be a mistake to look at what PGP and TLS are doing as a model for the DNS. I think it's much more important that we have a minimal number of cipher suites available in DNS.
Okay, thank you, DKG. Well, we had a good discussion here. There was also a good discussion on the mailing list. We definitely continue this discussion. There are clear positions and pro and cons this draft. But it's good we have the discussion and how to proceed. We will go on the mailing list.
So one
Paul,
quick request.
Please.
Yeah, one quick request is that before people discuss them on the mailing list, please read the draft because a couple of the comments from here were clearly people who hadn't seen where the draft was. So that would be great. And if people don't want it, that's fine. You know, the draft is changing the standard quo. So if they want to keep the standard quo, that's fine. We just drop the draft.
Yeah. I think you positioned the problem very well and a solution forward. And I think that we have now a good discussion in the meeting room, and hopefully, and definitely also on the mailing list. Yeah. Okay. Thank you, Paul. Going on to the next presenter. Okay. No, not again.
Hello.
Hi.
Can you hear me?
I can hear you, but I'm in a situation that I cannot open any windows anymore. Give me 1 minute. I have to refresh the session.
Sure.
Okay, I'm back. And we'll share my screen. Yeah, it's showing up. Okay, please go ahead.
Hello everyone, I am Thiru. I'll be presenting our draft DNS access denied error page. Next slide, please. I'll be quickly going over the problem statement and the solution that we're proposing and the security considerations. Next slide. DNS filtering today is performed by several networks for various reasons. Some of them are for security reasons, for example, blocking malware, phishing sites. Parental control is one other reason that is getting very popular nowadays. Several organizations have internal policies for blocking certain domains and domain categories. And filtering is also required by law enforcement agencies. For instance, if you look into enterprise DNS firewall, they typically block access to malware domains and phishing sites. Home network security is also primarily done using DNS filtering. MUD is an interesting one which talks about manufacturer user description, which defines ACL rules for IoT devices. Because IoT devices have a specific intended use, a whitelist of ACL rules can be created. For example, a light bulb can only talk to specific domains, and only those domains are permitted and rest all domains are blocked. So that would ensure that the IoT device does not communicate with any malware or command and control servers. And nowadays, several ISPs are also offering malware filtering service, and they do enforce DNS filtering because there's a court order or a request from the law enforcement agencies. Next slide, please. Now, the typical solution that at least the DNS firewalls and HTTP servers that were deployed for throwing the error page was to fake and was to spoof the IP address so that the client sends an HTTP request to the HTTP server and the user would see an error page. That pretty much worked for HTTP, but since nowadays you don't see any HTTP sites, and that's for good that the industry has moved to HTTPS. But the problem is if you have then the device would not be able to see the exact reason why the access to the domain was blocked, because the client would see a certificate error page. And what would happen because of that is either the client would repeatedly try to attempt to reach the domain because it does not understand why it's receiving this certificate error message, or it can go to the advanced settings and click and accept the certificate error message and proceed to see the domain page, even if there is a clear warning from the browser saying that the user is not supposed to visit the page because there's a security risk involved. The other risk that is involved is many devices nowadays have multiple interfaces, so the user may switch on to an insecure interface and try to reach that domain because the user does not know specifically why that domain was being blocked. The other solution that's typically used today is the user is asked to manually install the local root certificate of the enterprise network. And then the enterprise HTTPS server would basically spoof the server certificate and throw an error batch back to the client. But this requires the enterprise servers to start acting as MITM or TLS proxies. Next slide, please. And thanks to the new error codes that have been defined in this working group, especially the censored, blocked, and filtered error codes, it definitely gives a lot more information without just throwing a certificate error page back to the user. But there are some challenges that we've been seeing, that the user exactly does not know the reason why the domain is being blocked. For instance, if you see any DNS filtering service, it has several categories of domains because of which it is blocked. For example, it could be blocking a domain because it's a malware site, it's a botnet site, or a phishing site. And those sites and the reasons why the domain is blocked is actually a valuable information to the user. For example, if the DNS filtering service is identifying it's as a phishing site, it can go back and tell the user that, hey, if you connect to this site, you're going to lose your probably your financial username and password, transactions username and password, and could impact both your security and privacy, and impact you adversely with regard to your financial transactions. Unfortunately, that information is not available available to the user, and the user does not exactly know which entity is blocking the domain, whether it's my enterprise network blocking it or whether it's being blocked by some other entity. And typically, if you see, most of these DNS filtering services use advanced ML techniques for identifying, let's say, domain-generated algorithms or phishing sites, and there could be false positives, and the user needs to know the contact details of the IT infosec to raise a complaint, and that's not available because he no longer sees an error page. If you see the various categories because of which a domain gets blocked in any enterprise or home network are around 80 to 100 categories, and these categories are pretty much vendor specific and they cannot be standardized. The new error code forged answer that's defined, extended error code, does not work for HTTPS unless local cert is installed, and installing local cert is not a viable option, and it may work for IT managed devices only. Next slide, please. What we are trying to do in this solution is to define a mechanism where the error page URL will be returned to the client. We are relying on the HTTPS DNS record. We are introducing a new service parameter EOT in the service form so that it could provide the error page URL. It could be returned with any of the extended error codes, be it blocked, filtered, or censored. And the idea is to say that, hey, the browser definitely does know that, or the HTTP client knows that it's an forged answer, it's an error page, and can decide to display the error page back to the user. So in this example, if you can see, that's the URL, and the blocked domain is encoded in base64 URL encoding. Next slide, please. Yeah, and this brings various. I mean, if it happens in clear text DNS, I mean, it's pretty much possible that an attacker could modify it. So what we are discussing in this draft currently is DOH and DOT, especially in security strict privacy mode, is mandatory. Otherwise, the DNS response is susceptible to modification by any attacker. And further, this DOT DOH server has to be trusted by the endpoint. For example, it could be a pre-configured DOH or DOT server in the OS or browser. For example, several browsers nowadays support public DOH servers which do DNS filtering. For example, Quad9 blocks malware domains and phishing sites. And that way, the endpoint is for sure that it's actually talking to a trusted DOH DOT server and not talking to an DOT DOH server hosted probably an attacker. So that's an interesting one, that there's a lot of discussions happening in ad working group to figure out a trusted DOT DOH server so that the endpoint can start using that for filtering and other services that it offers. There are several advantages now that since the client explicitly knows that it is an error page, it can decide not to send any cookies, not to send any credentials. It can even go and disable JavaScripts. The other examples would be for just like similar to Captive Portal, it could auto-enable privacy browsing mode for the error page, or load the error page in a container mode isolated from other web activity, similar to some social networking sites being isolated from other web activity so that they cannot snoop into the other web activity. So since the client is now aware that this is as an error page and a spoofed response, it can take various actions to protect itself, even from a misconfiguration or even a trusted resolver giving a bad or a badly formed error page. Next slide, please. This is the non-normative contents of the error page. I mean, the error page is supposed to have the exact reason for blocking the access domain. For example, in this case, OpenDNS is a free DNS server which does filtering, and it's showing that the domain is blocked because of phishing, and the reason why phishing should be blocked. If it's blocked by a law enforcement agency, then a pointer to the regulatory text would definitely help the user to understand why access to the domain is blocked. And the organization which is blocking the access to the domain, in which case, in this example, it would be OpenDNS, and the contact details of the IT InfoSec team. And further, the error page should honor the ASP language header so that the error page would be displayed in the language that is written, that the user understands. And next slide, please. The error page could also even should not have ads or any dynamic content as well, because it's just unidirectional, just to say what's the purpose of the blocking the access to the error page. Any comments and suggestions are welcome on this draft.
Thank you very much. We have quite a number of people in queue. We are a little bit short on time, so I want to give everyone the mic, but please be brief in asking your questions. Ben, please go ahead. Ben? Okay. Yeah, there you are.
I think a click bounce.
Yeah.
First, as a matter of the mechanism, this is not a good use of the HTTPS record type. So I would strongly urge you not to do this using HTTPS, which is a way to indicate how to reach the page. Also, this formulation is not compatible with DNSSEC. So if you have clients who are actually correctly implementing DNSSEC, they will never see this record. In particular, if, for example, if there's a DNSSEC validating stub resolver between the application and the recursive resolver, which is a configuration that a lot of people here support, these errors will disappear.
Yeah, and this forged answer definitely comes as part of a server which does filtering. And today, as you know, that there are several servers in several deployments which do filtering. So NX domain is typically the response code which is returned for these responses, or it could be fake IP addresses, but that's the typical mode where DNS is performing filtering today, and this is nothing new.
Right. What I'm saying is that if the client validates DNSSEC, then this standard will not function, because the application will never see this HTTPS record. It will be dropped by the client due to DNSSEC validation failure.
Okay.
But so that's the first thing. The second thing is about the page itself. You've listed a lot of restrictions on this page, reflecting the fact that without those restrictions, this would be very dangerous. I'm glad you noticed that and provided all these restrictions. It's not clear to me that those restrictions are implementable in web browsers, which is clearly your target point. So we would have to go talk to web browser implementers. I suspect they would tell us that implementation of all those restrictions would be quite difficult. But even with all of those restrictions in place, this is not actually safe, because, or at least not safe to the standard that I would require. For example, I think it would be very straightforward for the server to simply provide a page that only contains a hyperlink that, when clicked, takes the user to, for example, a phishing page that resembles the Facebook login. So block Facebook and take the user essentially with one click to something that looks like a Facebook login but isn't.
Right, and that's the reason we mandate using a DOH or DOT server that's trusted by the endpoint. Otherwise, any man-in-the-middle attacker can just spoof responses.
Thank you. Next in queue is Jim. Please go ahead.
Thanks, Benno. Ben's point about DNSSEC was one of the issues I wanted to raise, so I won't bother repeating that. But I do think we've got another potential issue with how this potentially might be a violation of the DNS protocol. If the client is making a lookup, say for an A record or a quad E record, and it's going to get one of these HTTPS records in the answer section, how will the client behave? Because it's getting an answer to a different question from the one it asked. So maybe a possible solution for that would be to have an empty answer section response and the HTTPS record, or whatever it might end up being, going into the additional section. But then we still have this issue. We still have this issue with DNSSEC.
Yes, so the draft currently says it's not part of the answer, and it's part of the is an additional record in the additional data section. We have that mentioned in the spec.
Okay, my apologies. I thought you said it would be in the answer section.
No, yeah, it's in the additional section.
Okay.
And it will be only returned when the extended error codes are returned. So it has to be returned along with the extended codes, censored, filtered, or blocked. So the client will not process this additional record or the new parameter that we are introducing unless it is capable of processing the error messages, the new error messages. And those error messages will be obviously inserted by a DNS filtering server, and it can also insert this error page URL.
Okay, thanks.
Thank you. Next is Jonathan. Please go ahead.
Hi. I just want to say that concerns aside, I really appreciate a draft that focuses on making things easy for end users, giving them information they need, giving operator, customer support folks a mechanism to further help end users. So I appreciate the focus on that, regardless of the implementation concerns. Thanks.
Thanks, Wes.
Thank you. Wes, you have the mic.
I'm going to try and limit the comments. I think there's a lot of interesting ideas here. We talked about better mechanisms for returning errors in EDE, and it was generally decided that no, it was not a safe thing to do, and this isn't safe either. I mean, just do and dot doesn't even protect you to the resolver. Upstreams, if the resolver is being attacked and sent random HTTPS records, it would still redirect the client. So you essentially have an unsecured redirect, without a signed error. And that can't happen if the resolver is trying, of course, as people have pointed out, it doesn't play well with DNSSEC in the first place. And doesn't it also allow, like malicious ISPs to basically insert a man in the middle, showing the page that the user wanted to get to, but going through, a man in the middle sniffer as well. It doesn't seem like a safe idea to me.
Hey, Eric, that's a good point. I mean, we don't want this to happen over clear DNS, so it mandates that the endpoint has to have a DOH or DOT configured, and it has to be something that's trusted. For instance, if you have a browser or OS which has pre-configured list of DOT DOH servers, for example, today Firefox trusts Comcast, right, and Chrome uses several DNS filtering servers like Quad9 and OpenDNS, and they are the ones that it trusts that they do the filtering already, and it blocks access to various domains for security reasons. And that way, those DOH DOT resolvers can be trusted to provide this error page URL, and not by any bad ISP or an attacker who is in the network or somewhere in the internet.
Okay, sorry. Next.
Yeah, we have a whole section on that discussing
sorry,
this point in the security considerations, so
you
may want to have a look at it.
We have to be very brief now because we are running out of time, and we still have 4 people in queue. Please be brief. Eric.
Hello, can you hear me?
Yes.
Okay, great.
Thank you.
Yeah, I'll try to keep this brief as requested. So I want to express some general support for trying to solve this area within Chrome. This is an issue we've been discussing lately and trying to find a solution for that we want to get out of the current solution of this filtering the way that we forward address results to get stuff. Continuing the discussion of everyone saying that there's the security issues, I'm not sure if we would be able to trust it as is, so it's certainly an area we need to continue the discussion on, decide if it's good. And also expanding further on some of the comments on the exact nexus of sticking in HTTPS, I think it would be a bad idea to do anything that requires forging results. The recursive is not authoritative for the HTTPS results for this name, so it should not be creating or modifying HTTPS. That's just going to lead to problems in the future. The reason the current stuff doesn't work is because all the technology tries to fight against anything forging results. So maybe something EDNS 0 like EDE did would be a better way to go. I don't know.
Sure, Chris.
Thank you. Chris, please go ahead. Can't hear you, Chris. I will keep your mic open. I will go on with Warren. Please, Warren, go ahead.
Sorry, no hats. I'll keep this really short. So along with many other people, I think I really hate the idea of DNS filtering. However, the internet doesn't really care what we think. People are going to do DNS filtering, and so I think we need a way to make it as non-harmful as possible. I think that this is one of the ways, providing that there is a good way to signal to the browser and from the browser to the user that this is happening. Browsers already do stuff like sort of sandboxed environments for things like captive portal pages. So if we could have a way where the browser would agree to have a huge red border around it, not allow any other links to be followed from that page, only static type text, which shows this is what happens, and you cannot use any links within it. You cannot use any JavaScript, etc. I think that might be okay, but I do think that it needs some strong discussion with the browser vendors to agree on, how it can be carefully sandboxed and only used for display, not for anything else. And
agreed. Thanks for the comments.
Okay, thanks. Ecker, please go ahead.
Yeah, I guess I don't think we'd be super enthusiastic about this, we being Firefox. If you look at safe browsing, there's a relatively really small bandwidth channel that we can be told what the problem with the site is, and we won't go there. But we want to control that interface. We don't want to delegate that interface out to the out to some other party. It was noted that you use the trust resolver, but the trust we extend the resolver is extremely limited. The trust we extend the resolver is about how it handles your data. But we assume that the primary mechanism for preventing hijacking the connection is TLS. It is not the browser, not the resolver returning the correct answer. I'd be pretty wary of accepting arbitrary stuff, even in the sandbox, as Warren suggests.
Okay.
Okay, thank you. Victor, I did close the line at Ecker, so if you have a very, very brief question, please go ahead. But really brief, because we also want to have Jordi give his 1 minute pitch of his proposal, his draft. Please go ahead, Victor.
Two things very quickly. One on the DNSSEC question. So long as the additional section doesn't actually use the queue name that the user asked for, it can be in some clearly unsigned portion of the namespace. That might help. The other thing, in terms of trusting this just because it came over DOT, forgets that the DOT resolver in turn often makes unauthenticated connections over the public internet to authoritative servers, which can be easily MITM'd. So the amount of trust we can have in this is limited. And I think DOT is too heavy-handed in any case and should not be required for this protocol. Doesn't add much, just creates false sense of security, I think.
Yeah, Victor, that's a good point. And if you see, we are working on the draft to enhance to say that this mode of DOT would only work when strict privacy is enabled. Opportunistic DOT has two modes. One is strict and opportunistic. Opportunistic is the one that you're referring to, which is the server certificate may not be validated, but strict mode definitely requires that the client has to validate, and is very similar to what DOH is doing today.
It doesn't solve the problem. It does not solve the problem.
Okay. Thank you, Victor, for raising this point. I think we definitely have to go further with the last presentation in the last 4 or 5 minutes we still have. Please continue this discussion on the mailing list. Thank you for your contributions, also the presenter. I want to go further with Jordi. He will give a 1 minute pitch of his work in V6 Ops. If I have the working group correct, I think so. Please, Jordi, go ahead. It's related. Sorry, it's related work. So it's not DNSOP work, but it has impact on our working group. So that's why we scheduled this presentation. Oh, you're muted, Jordi.
You hear me now?
Yeah. Yeah.
Okay.
Excellent.
So this is a B6Ops work related to optimization of 464XLAT, and because we are using the DNS64 synthesized records, we want to make sure that we are not breaking anything else. We don't have time for the full presentation, but I think if you look at the slide set, it's very easy to follow. The last version of the draft was published about 2 days ago. The main difference we have now with the previous version is that we are including in the translation table the MAC address. So we want to make sure that we only optimize if it's an IPv4 only host. And I will ask everyone to see the slides, to send me inputs in B6Ops or in private, as you prefer, and we can keep improving the document. Thank you very much.
Thank you, Jordi. And with that, so please review the document and have the discussion in V6Ops. With that, we are coming to an end of the second session of DNSOP working group. Thank you for your patience with me. The second session was a little bit smoother than the first one. I was learning on the job. We also had 2 very good discussions on 2 drafts. Please continue the discussion on the mailing list, and we will see there. We will see each other over there on the mailing list. We also make a summary. The chairs will make a summary of all the documents being presented and the actions for the working group chairs or for the authors. And that's it, I think. Suzanne, do you have some final words?
Only thanks for everybody, particularly for our patience with us and some new tools. This all virtual thing is always challenging, but also for one thing, as far as timing, it's always been a challenge, and it seems to be harder with the fully virtual meeting. So we'd appreciate sort of if you drop a word in Benno's ear or mine or Tim's. In particular, if we're going to have trouble juggling timing, would people rather we move things around next time and departed from the published agenda? Because we do have some flexibility, but in the past, the working group has been very uncomfortable with us moving presentations around. So if you have new input on that, please do let us know. Other than that, thanks very much for everything, and we will see you out there. Thanks very much. Bye for now.
Thank you. Bye-bye.